So particularly what we're going to do is develop a software interface, which is going to allow a user to extract electricity consumption over the course of the month for one of the facilities on the Lummi Nation. The Lummi Nation is a Native American tribe, so it is located in the northwest portion of the country. I think it's in Washington. The reason I picked this data set is we worked with it a lot this semester in the Intro to Engineering course, so it was just something that I had handy that would be a good use case for demonstrating all those functions that we spoke of at the beginning. So what this data set is it's the consumption data. Remember that electricity consumption is measured in units of kilowatt hours. When you hear kilowatts, immediately you think that's a unit of power. But when you multiply power times time, of course, that will convert that quantity to total energy consumption, since power is the time first derivative with respect to time of energy. So over the 2020 calendar year, in 15-minute increments, this gives you actual consumption data for 10 different facilities on the Lummi Nation. And what we're going to do is to write a script that imports this entire file and then allows a user to visualize the consumption over the course of the month for one of the facilities and then reports out how much actual electricity was consumed over that month. So what we're going to be doing, the first thing you want to do is actually download this file from our Canvas site. You'll notice it is an Excel file and it is stored under the Files tab in the Final Project folder. So if you have any issues finding that, please let me know. I'll also post it in this week's module. And then what we want to do is to write a script that first and foremost imports that data from the spreadsheet into a MATLAB table. So I'm just going to copy this file name. And hopefully everyone remembers how to do that. If you don't, remember that the first thing you need to do is to go to, drive.matlab.com. And once you've downloaded that file locally to your machine, if you're using MATLAB Online, you'll want to upload that file to your MATLAB drive, wherever it will be at. For me, I downloaded it in my downloads file, so there it is. I would double click on it and I would upload it. I've already done that. I know some of you are working with the MATLAB application locally on your machine, and if you are, of course, you just want to download it to wherever the actual whatever the working directory is for your MATLAB application. So on step one, I gave you a hint. It's a hyperlink. It says hint for part one. It just goes to the help file of read table. You can also just look at that help file directly on the command line by typing help and then the name of the function, and you can read through it there. My favorite way whenever I'm working with something, I always say software is free. You can't break it, so just try to use the function. So what do you think read table would do? Well, it's probably going to read in a tabular data format from a file that contains tabular data, in this case, an Excel sheet. So I'm going to name the table for which I will be storing the data from that file, maybe consumption data. So that's a variable name that I picked. It's semantically meaningful because it describes what we have here. And I'm going to use the function read table, and whatever read table returns, I'll assign it to that variable. Notice it naturally wants to pass in a file name. There are other options that you can use. You can dig into those if you want, but just start to type the name of the file, which is Final Project Data, Lummi Nation. And as long as it's either in your MATLAB drive, if you're working on cloud, or in your local directory, tabbing should autofill. And tabbing is very important because if you think about it, if you type identifiers manually, that's how you have the capability to introduce syntax errors. Always good practice when you're building a script to execute it line by line and make sure it does what you think it would do. So when we use read table, we take the data in this file and we actually import it into our workspace into a variable which we name. We can double click on it and look at it in the actual user interface here and see that there are 11 columns. One is a timestamp. The other 10 columns are the consumption data for the various facilities, and we have quite a few rows because remember this data is in 15-minute increments over the course of an entire year. So that's what you want to do for step one. For step two, we want to ask the user to specify the facility they're interested in exploring along with the month of interest. Please note that the month of interest should be entered in integer format between 1 and 12, and the facility should be entered as a string. To receive full credit for the project, you should also validate the user's input in both cases. So this is going to go back to what we did in lab last week. I think it was last week, maybe the week before, where we use a while loop to kind of reprompt the user to enter a valid value until they actually do so. So in terms of actually getting the facility input, the list of valid facilities, you could manually look at the file or look at the actual data in the workspace and create an array of all the facilities, typing the names manually. That is not ideal. What you'll note is that MATLAB, in addition to all the other characteristics that we've given it, is also an object-oriented programming language. And these tables are actually objects. And what object-oriented programming means is that variables also have certain attributes or methods built into them, natural functions that can be performed on that data type that you can call, typically using a dot notation for syntax. So if you have consumption data, which remember is a table data type, and you actually type it on your command line, and you type dot, and then you type properties and autofill, and then you type dot again, you'll notice that there are quite a few different properties of that table that you can return. So if you look here, one of the property that you can return is the variable names. And there are 11 of those, of course, because you have the timestamp and then you have your 10 facilities. We haven't talked about this data type in MATLAB, but what you're actually going to get is a cell array. Remember, since it's free, just kind of see what happens when you hit enter. And you notice you get all of the different names of the facilities. So what I'm going to do is just take that line of code, and I'm going to, sorry about that, I was trying to control X. Sometimes MATLAB Online, the user interface is not great. And I'll put like something like valid facility names equals this. And the way that you actually want to check, like, so we know if you look, school is a valid facility name. So when I define the valid facility names, like in your validation, like the while loop that you all did in lab last week, what you want to do to build a logical case to check whether or not someone has entered an actual valid facility is to use the isMember function. So just check this out. So if you think about Ferry as a valid facility, so if I ask MATLAB, is Ferry a member of the valid facility names that I defined above, notice that I get a logical 1. So that's something that I could use in a while loop in order to actually ensure that the user has entered a valid facility name that's actually included in this file, versus if I checked if Henry was a valid facility name, it would not be. Right, that would be logical 0. So you can actually do the same thing when you ask the user to enter the month in the format of 1 to 12. If you had something like valid months equals 1:12, remember the colon notation makes an array from the start point to the stop point. If there are only 2 values, that means that the step is 1. So if I define valid months 1:12, that will be 1 to 12, and then I could use isMember, and I could put, like, if the user was trying to be control me and they entered 14 for a month, I could just say isMember is 14 within the valid months, and the answer there is of course no. So you can do the greater than or equal to and the less than or equal to like we did for the input last week. However, this is actually a better way to do it because it also ensures that the user that was entered is actually an integer in that case. So let's move on. So you're basically gonna prompt the user to enter a facility name and enter a month between 1 and 12, and then you're gonna check that the actual both of those inputs are valid. I gave you some helper code down here. If you want to display all of the facility names to the user, here's how you would actually do that. So just to show you how this actually runs, and I'll make sure I use the same identifier here. So you're gonna wanna make sure here that I called this consumption data here. And this is actually, here's the final actual code that works. I coded this before I started to record the video. It could definitely be improved, but that is fully functional code. So whatever you name the variable name that you import from your actual file, just take the code that I gave you at the bottom and make sure that that identifier matches the variable names that are being extracted. But basically what this code does is it extracts all of the valid facility names, which are the header or variable names from that file. And what it's going to do is use a for loop to create a concatenated string. Hopefully everyone remembers that idea of string concatenation that we talked about in an earlier lab that contains each of the facilities. So the reason I'm starting at 2 is, remember, the first element of valid facility is actually the timestamp name. So I'm going to initialize a blank string, and then for each of the facility names that I want to put in the loop, I'm basically going to create a new string, right, which is the old string, and it's going to start out blank, and I'm going to append on the current facility name in the loop. So let me just show you how this actually looks, and the way that I'm going to show you is to take off this semicolon, and I'm actually going to run this code. And I'm having a little bit of an error here. Where is it? Line 8, column 39. This is something I pasted at the bottom here. Where are we at? The valid facility names. Oh, I see. I wonder when I copied that, just so everyone can see, let's make sure it's right on the actual, yep, it's right on there. So must have just been an error. Oh, sorry. Actually, you're getting to see coding actually done in real time here. The valve facility names are, what am I trying to do? There we go. Actually, I don't need that. So there's the actual, what I'm missing. So now that I've caught that bug, let me show you what it is actually going on. So not sure how that got cut off in the copy and paste, but that happens sometimes. So before we have a chance to mess that up, sorry to let you all watch an error here in real time. But what was going on is, and this happens a lot when you copy and paste text from like a more sophisticated application like Microsoft Word to like a more notepad application like the MATLAB text editor. Oftentimes metadata will modify what you're copying, but basically this is the literal string the valid facility names are, and I want to append onto that when I use the display function the actual string that I built up through this for loop. But let me actually show you how this works. And I don't think I think I've shown you all how to debug before, but the way you do it is you just click on a particular line number on the left side here, and then click run, and it will run to that line and it will keep going. So this warning is from basically the way that Excel file is structured. You don't have to actually worry about that. There is a way to suppress the warning if you want to do that, or you could even modify the header structure of that file to get rid of the warning, but we're not going to worry about that. So what's going to happen here is this code, valid facility string is blank now. So we're going to create a new string called valid facility string. It's going to take the blank string and it's going to put on the kth element of the actual valid facility cell array. And remember, k is 2 right now. So, and then I don't have a semicolon here, so that will display kind of my concatenated string to the actual interface. So if you notice the second element in that string was school, what this little thing is doing here at the end is it's putting in a comma and then a space. If you didn't have this, it would just be all the names of the facilities right next to each other. There would be no delimiter. So we'll run again, and you notice now it's going to take valid facility string has, if you want to actually see what's in it, at school. So we're going to put to the right of school the third element in the list. And you notice when I execute that line, now I have Youth Academy, and so on and so forth. And if I just run this to the end, it's eventually going to put all of the facility names on there. And then once it's billed, usually when you hit continue, it goes to the end. There we go. The valid facility names are, and you can see everything there. So let me got too excited. Let's clear the command window. But that is what that code is for if you'd like to include it. There's other ways you can do it, but that's one way that you could display all of the valid facilities to an end user. So once you've got that information and you've ensured that it's valid from the user, what you want to do is actually extract a subset of the data that the user is interested in. And here's the way that I think I would do it. So say you had like, let me comment this out, and we'll just start to work down here. And we'll breakpoint. And actually, I'm going to delete all this because your code will have a lot more, and I'll show you how it looks completed here in a minute. But just say like the user month was 2. They wanted February, and say the user facility was school. So you'll have complete validation above this, and you'll actually get these values from the user. So what we want to do is in consumption data, get all of the, let's pull this up, all of the, let me see if I can maximize it here. There we go. All of the rows that have whatever month the user is entered. So for example, in the case of February, we go all the way down. It's going to take a very, very long time. So let me see if I can actually jump here. There we go. Some days like this, you miss teaching in person because it's a lot easier to show you. There were some February days. I got too excited. Anyways, you can see there's going to be a subset of rows that correspond to days in February. So days in January are like everything from row 1 all the way down quite a bit more. And then we also, so we want to take a chunk of the, I'm going to actually turn my camera back on here to show you what I'm trying to say. There we go. So in that table, you're going to take a chunk of the rows. Okay, let's go down. A chunk of the rows, that's kind of like in the horizontal direction. And you're going to take one column corresponding to the actual facility name. So what you need to do is filter that table, only get the rows you want, and then hopefully I can figure out how to close this. There we go. And I'm going to go back to my natural 2-column layout. Those of you that are using this on your actual desktop are very intelligent, because this is a pain to do. So we have consumption data, the table stored. We want to extract all the rows that correspond to the month February, which is encoded by 2, and all of the column corresponding to the school data. Here's how you actually want to do that. So if you look at consumption data, so I'm going to create a new variable called valid rows. This is going to be the rows that correspond to whatever month the user has entered. So again, using that idea of an actual, the consumption data table being an object, I can use the dot notation. Remember that timestamp is the actual first column corresponding to the timestamps. And what I want to do is do consumption data dot timestamp dot month. So let's just kind of execute that method on this actual tabular data type and see what happens. If you notice, you get a bunch of numbers, and maybe you can plot it. It would make it actually look a little bit more easy to deal with. It should look like a step function, because the first part of data is going to have month of 1, then it will go to month of 2, then it will go to month of 3, and so on. So we basically what we've gotten here is the actual month value in every row. So what I want to do is I want to compare that to, and remember that a comparison, going back to the lecture we did where we talked about the comparison operators, double equal basically tells whether or not on a row-wise basis the number on the right is equal to the number on the left. So if I did like consumption data.timestamp.month, which is going to be the month of all of those rows, equals 2, I would expect that I'm going to get an array that's going to have, since there are 35,040 elements in this table, it's also going to be 35,040 elements long, but it will either be 0 or 1, and it will be 1 for the rows where the month is 2, and it will be 0 elsewise. So if I just run that real quick, it's going to be hard to see. But again, if I plot it, I might be able to get a better visualization. So let me do that. And you can see it's kind of picking out, it's 1 over the range of the rows where the month is actually February. So that's what I'm going to use for. Let me close that again. And then I think I was calling this test script, hopefully. There we go. Okay. So I'm going to have the way that I'm going to filter from my valid rows is I'm going to extract the actual numerical month value of all of the rows from my table, and I'm going to compare it to the actual user month. So this is basically going to give me a filtering screen that I can use in order to only extract the rows of the table that I want. So now what you want to do, call it final data to be the actual portion of the table that you want to extract. And you can say that it's going to be the entire table, consumption data. And I'm going to show you here why you don't just use parentheses, but I'll use parentheses for now. I want all of the valid rows that I just specified with that screen. And then if the user facility is specified as school, I don't think I executed that yet, I can just pass that string directly in to tell MATLAB which column I want. So let me actually just execute this and you'll see what's going on. Sorry about that. Let's actually look at, valid rows wasn't defined. So define valid rows. And remember, all of this is going to be in a bigger script, and I'll show you what it all looks like in a minute. But if you define user month and you define valid rows here, now you can make an extraction of, and I'm going to terminate this because it's going to be really big, only the rows that you want and only the column that you want. So if you notice final data, now it's a table as well. It has 2,784 rows. Those correspond to only the timestamps in February, and it only has one column corresponding to the facility of the school. So if you double click and you actually look at that, you can see it's also a table, but basically what you've done is you've only extracted the, maximize again, you've only extracted the rows corresponding to the timestamps in February. That's why there's not as many rows to that. So to finish this out, I'm going to go to layout and to column again. The problem is if you take what you have here, and remember, you're going to want to plot it. So if you try to plot this, the issue you're going to run into is that plot doesn't work on tables. So when you're actually working with a table and you're going to be extracting something, and that's what that error is basically saying there, if you look at the syntax error. If you want to extract just basically an array of values from a table, rather than using parentheses, a shortcut to do it is to actually use curly brackets. If you notice, if I re-execute this command with curly brackets, and then I plot the value that I just extracted, that actual value is just a numerical array. And this is the consumption data basically in the school over the course of the month. And you notice that you got peaks corresponding to the actual days that the school is open. And then there's a periodicity or seasonality to it. You have over the course of the weekend when the actual school is closed, more minimum values, but it's never zero, right? Because there's always going to be some minimum electrical consumption to basically keep that building operating. So that's how you actually do the extraction. So once you have the extraction, you can read the description here, but generate that plot and then display to the user the sum of all of the values over the course of the month. So just to show you how to do that, you could say like display and then concatenate a string. The total consumption for the month was, and then we can put in num to string call and basically just sum up all the final data. So when you call that sum final data, it's just going to take all the numbers in the array and add it. So there's how that could look. The total consumption was this. You probably want to put on the units. So just add on an additional string at the end, kilowatt hours. There you go. And you could round that if you want. You can make this as pretty as you like. So just so you know kind of what you're targeting when this is eventually done, this is a script that's fully functional. It's not perfect. Again, I wrote it like in probably like 10 minutes after I wrote the actual code. So, and it probably will take you longer than 10 minutes. I've been doing it for a while, so don't expect, this should take maybe a couple hours to actually write. But here, I don't want to actually show you how it works, but I don't want to show you the code, but I do want to show you how it works. So at least mine. And again, you can turn that warning off if you go to the help of read table. You can see how to suppress warnings. But say I entered a desired month of like 90, that's not a month. It will tell me not a valid month. Please try again. Now say maybe I want April. Now it's going to tell me the valid facility names are school, youth academy, the Cove, casino, and so on. I'll tell it I want the casino data. It's telling me the total energy consumption for the month at the casino was 456 megawatt hours, and there is the actual consumption in the casino over that month. And if you notice, it has some periodicity to it as well. And remember here that these timestamps are in 15-minute intervals. Maybe if you really wanted to be very, very have a very nice presentation, one thing you could do is like sum all the data over the course of the day and only plot the daily consumption, because someone that is looking at it over the course of the month, they're probably not interested in the seasonality within a day. They'd probably rather just see the consumption on a per day basis. So if that's something you want to do to kind of see how far you can take this, feel free, but I do want to have a pathway where you can get full points without having to do that additional work. So that is what I'm looking for. I'd like you to turn in your script, and I'd like you to turn in some pseudocode. The only reason I'm asking you to turn in pseudocode is I hope that everyone will do that before they actually start coding. And that's just the process of saying, okay, in order to do what he's asking me to do, I need to do this, I need to do this, I need to do this. And hopefully your pseudocode will be more than just the 3 steps that I have here. Like 1 maybe is like 1-to-1. You just have read in the table into a variable. But 2 here, like you should have multiple steps in your pseudocode code corresponding to that actual